This is a video from section 3.1 and it's on the derivative rules. Note, this notation that I'm highlighting with a rectangle is the derivative of f of x with respect to x. So for rule number 1, the derivative of a constant with respect to x is equal to 0. Now let f of x equal c. We want to show that the derivative of f of x with respect to x is equal to 0. So in other words, we want to show that f prime of x is equal to 0. Now, f prime of x is the limit as h goes to 0 of f of x plus h minus f of x divided by h. Now, f of x plus h is equal to c, and f of x is equal to c. So we could write this as the limit as h goes to 0 of c minus c divided by h. But remember that c minus c is equal to 0, and 0 divided by h. Remember, h is not 0, h is approaching 0. And so 0 divided by h is, in fact, 0. So this can be written as the limit as h goes to 0 of 0, which is equal to 0. And so that says that f prime of x is in fact 0, which is what we wanted to show. And in fact, we can use the definition of the derivative to verify all of these rules that I'm going to go over here. In rule number 2, this is the power rule, and it says if n is a positive integer, so in other words, if n is 1, 2, 3, 4, and so forth, that the derivative of x to the n with respect to x is nx to the n minus 1. So in this rule, I just want to take a look at a few examples here. Suppose I had the derivative with respect to x of x squared. So I'm going to take the derivative of x squared with respect to x. In this example, n is 2. And so I'm going to write this as 2x raised to the 2 minus 1. Okay? But 2 minus 1 is equal to 1. So this is 2x to the first power, which is 2x. For example 2, suppose I want the derivative of x to the 5th. In this example, n is 5 right here. And so I'm going to bring the 5 out in front, and I'm going to write the x down and raise it to the 5 minus 1. Okay? But 5 minus 1 is equal to 4. And so this is 5x to the 4th. So the derivative of x to the 5th with respect to x is equal to 5x to the 4th. Rule number 3, and I have some examples worked out here. This is the generalized version of the power rule, and it says if n is any real number, then the derivative of x to the n with respect to x is equal to nx to the n minus 1. And remember, n can be anything. It could be a square root, like square root of 2. It could be pi. It could be e. It could be anything. So let's take a look at a couple of examples here. Suppose I want the derivative of x to the 2.1 with respect to x. This is equal to 2.1x to the 2.1 minus 1. Same principle as rule 2, okay? So in this example, again, n is 2.1, okay? Now 2.1 minus 1 is 1.1. So the derivative of x to the 2.1 with respect to x is 2.1x to the 1.1. So that's how you would do example 1. Well, if we take a look at example 2, suppose n is 1 in this context. That is legal because n is a real number, okay? And I'll give you a more visual demonstration of why that's true when we're in class, by the way. But in this example, we'll apply the power rule. And so the derivative of x to the first with respect to x is 1x to the 1 minus 1. So again, I want to stress that n is 1 in this problem. Now, 1 minus 1 is equal to 0, so this is 1x to the 0, which is equal to 1. And so therefore, the derivative of x to the first, or x, okay, with respect to x is equal to 1. And that's how Rule 3 works. If we take a look at Rule 4, here we have if c is a constant and f is a differentiable function, and that just means we could take the derivative. It says that the derivative of c times f of x with respect to x is c times the derivative of f of x with respect to x. So in other words, I could take the c and pull it out in front of the derivative. So in this example, we have the derivative of 5x cubed with respect to x. And so here, I'm going to take the 5 is constant, I'm going to pull it out in front and take the derivative of x cubed with respect to x. Now, the derivative of x cubed with respect to x is 3x squared. And remember that the 5 is going along for the ride. And so this is 5 times 3x squared, okay? But 5 times 3 is 15, so we get 15x squared. And so the derivative of 5x cubed with respect to x is 15x squared. Rule 5. If f and g are differentiable functions, then we have the following. The derivative of f of x plus g of x with respect to x is equal to the derivative of f of x with respect to x plus the derivative of g of x with respect to x. So in other words, we can split these up. And the derivative of f of x minus g of x with respect to x is the derivative of f of x with respect to x minus the derivative of g of x with respect to x. Now, I want to put a big note down here, okay? If I take the derivative of f of x times g of x with respect to x, this is not, and I repeat, this is not the derivative of f of x with respect to x times the derivative of g of x with respect to x. And we can give a pretty quick counterexample to this, but I want you guys to think about this. Now, I can let f of x equal x, and I'm going to let g of x be x squared. And if you try to take the derivative of x times x squared, you're going to get one answer. And if you try to take the derivative of x and times it by the derivative of x squared, you will absolutely get a completely different answer. But that's one I would encourage you to try. So this is very important. It doesn't work for products, and this rule doesn't work for quotients. Okay? It doesn't work. It only applies if you have the sum of two functions and the difference of two functions. So we want to make sure we're very aware of what's happening here. And the last rule, it turns out that the derivative of e to the x with respect to x is equal to itself, e to the x. Now, what we're going to do here is we're going to differentiate the function. Now, I'm picking the problems directly out of Stewart, 9th edition. And what I want to do now is I want to take a look at number 4. Don't get thrown off by the t. It's just a variable, okay? And I'm going to show you how this works. So g of t is equal to 5t plus 4t squared. So I'm going to write this out for the first couple of examples longhand, and then I'm going to show you how we're going to do this in practice. Okay? So g prime of t is the derivative of 5t plus 4t squared with respect to t. Okay? But this is the derivative of 5t plus the derivative of 4t squared. So remember that the derivative of a sum is the sum of the derivatives. Now, here's a 5, here's a 4. And remember, we can pull those constants out in front. And so I'm going to take 5 times the derivative of t plus 4 times the derivative of t squared, in fact. And in both cases, it's with respect to t. Okay? Now remember, we're differentiating with respect to t. And so the derivative of t is 1. Remember, in this example, this is understood to be t to the first. Okay? The derivative of t is 1. The derivative of t squared with respect to t is 2t. So this is 4 times 2t. In this case, n is 2. And so this is 5 plus 8t. 4 times 2 is 8, right? And so therefore, g prime of t is equal to 5 plus 8t. So this is one where I applied the derivative rules all the way through, the whole time. Let's take a look at number 8. Suppose f of t is t cubed plus e cubed. This is a great question, and it's a trap question that we want to be aware of. Okay? Now, when I want f prime of t, this is the derivative of t cubed plus e cubed with respect to t. But the derivative of a sum is the sum of the derivatives. And so that allows me to take the derivative of t cubed with respect to t, and I'm going to add it to the derivative of e cubed with respect to t. But the derivative of t cubed with respect to t is 3t squared. The derivative of e cubed, remember, e cubed is constant. The derivative of any constant is 0. So I'm going to put a 0 here. And then when I'm done, I get 3t squared. And so therefore, f prime of t is 3t squared. And I'm done. Let's take a look at some more examples. Suppose I had number 12. V of t is equal to t to the negative 3/5 plus t to the 4th. Again, don't get thrown off by t versus x. It's just in context, we're taking the derivative of this function with respect to t and not x. So if I want v prime of t, now what I'm going to do is I'm going to take the derivative of the first term, which is negative 3/5 t to the negative 3/5 minus 1. Okay? Because in this example, n is negative 3/5. And then I'm going to take the derivative of t to the 4th, but the derivative of t to the 4th is 4t to the 3rd. So this is negative 3/5 t to the negative 8/5 plus 4t to the 3rd. Now, I want you to be able to write this as a single fraction. And that's going to become important when we reach chapter 4, okay? And so this is negative 3 over 5t to the 8/5 plus 4t cubed. And we're just going to say divided by 1, okay? And so here, I'm going to multiply the numerator and denominator by 5t to the 8/5. And when I do, I get, in the denominator, I get 5t to the 8/5. In the numerator, I get 20t. Now, 3 is the same as 15 over 5. And 15 over 5 plus 8 over 5 is 23 over 5. And then I'm going to subtract 3. And this would be, in fact, v prime of t. And that's how you do problem 12. If we take a look at problem number 18, suppose w of t is equal to square root of t minus 2e to the t. Now, the way square root of t works is I'm going to write this as t to the 1/2. So w of t is t to the 1/2 minus 2e to the t. And so I want w prime of t. Now, I'm going to apply the power rule to this first term. And so when I do that, I get 1/2 t to the negative 1/2, right? And 2 is constant, so it goes along for the ride, and then I got to take the derivative of e to the t. So this is 1/2 t to the negative 1/2 minus 2 times e to the t. And so this is 1 over 2t to the 1/2 minus 2e to the t. Now, if we get a common denominator, right, 2t to the 1/2 is in the bottom, and in the top, we're going to get 1 minus 4t to the 1/2 times e to the t. And that would, in fact, be the derivative of w of t. And we're done. So that's problem 18. If we take a look at problem 20, so we'll do a couple more examples for this video. Suppose f of t equals 2t minus 3 to the second. Now, remember, this is section 3.1. We don't have any techniques on how to handle something like this. But what we do know how to do is square that out. And that's exactly how this should be handled. So this is 2t minus 3 times 2t minus 3. Okay? Now, 2t times 2t is 4t squared. And then minus 6t minus 6t is minus 12t. And then negative 3 times negative 3 is positive 9. And so, therefore, f of t is 4t squared minus 12t plus 9. I do know how to do that. So when I take the derivative, I'm going to write down the 4. And the derivative of t squared is 2t. Minus, write down the 12. And the derivative of t is just 1. Because remember that the exponent is 1. And 9 is constant, And the derivative of any constant is 0. And so, therefore, f prime of t is 8t minus 12. And that right there is problem 20. In problem number 24, so suppose y is equal to square root of x plus x divided by x squared. Now remember, again, this is section 3.4 or 3.1. We don't have any techniques yet. So what we need to do for a problem like this is the following. We're going to split off the fraction, and we're going to write this as square root of x over x squared plus x to the first over x squared. Okay? Now, this is x to the 1/2 divided by x squared plus x to the negative 1. Because, again, remember, we don't have any thing to work with yet. So y is x to the, now 1/2 minus 2 is negative 3/2 plus x to the negative 1. Now y prime is negative 3/2 x to the negative 3/2 minus 1, right? So I'm just applying the power rule to this first term. And then I'm going to apply the power rule to the second term and add them together. So I'm going to get negative 1 x to the negative 1 minus 1. So this is negative 3/2 x to the negative 5/2 minus x to the negative 2. And so this is negative 3 over 2x to the 5/2 minus 1 over x squared. Now, I'm going to get a common denominator because, again, I do think it's good practice for us to be able to do that. Now, remember that 5/2 is the same as 2.5, right? And so I'm going to multiply the numerator and denominator by x to the 1/2. And again, I'm going to actually take it a step further. I'm going to multiply the numerator and denominator by 2x to the 1/2. And I'm doing that on the second term, by the way. Okay. This becomes important, again, to write these derivatives as a single fraction when we get to chapter 4. So when I'm done, I get y prime is negative 3 minus 2x to the 1/2 divided by 2x to the 5/2. And that would, in fact, be the derivative. And that's going to do it for this video for section 3.1. We went over all the derivative rules for the section, and we worked on some examples of taking derivatives. And again, I took the examples directly from the textbook. Okay, thank you.